Thank you for joining us for the next instalment of the TUFLOW Modelling Tips series. Today's presentation will be of most relevance to our Australian users who are using Australian Rainfall Runoff 2016. Australian Rainfall Runoff 2016 introduced 3 assessment methodologies to us. Now, of those, the Ensemble approach, which is the most commonly used, has effectively increased the volume of simulations that are required by a factor of 10. Now, a common question we get through TUFLOW support is, how can we post-process those results efficiently? Fortunately, we've developed a free utility to help with that post-processing, and we'll give a live demonstration of that utility today. Before doing that, however, I'll show you where you can download AsctoAsc. Simply go to the website, click on Downloads, and click on the Utilities tab, and you'll find the AsctoAsc download is second from the top. I'll pass you over to our QGIS expert, Ella Simmons now, who will give you a live demonstration how to use AsctoAsc.
The AsctoAsc utility can be used to extract statistical information from resulting TUFLOW grids. This can be useful when performing analyses using Australian Rainfall and Runoff 2016. In this video, I will demonstrate how to set up and run the utility to process the results, as well as briefly explain the outputs. For this example, I have a max water level result for one event duration combination with 10 ARR 2016 temporal patterns. So you can see I've got the 1% 120-minute storm event with temporal pattern 1 all the way down to temporal pattern 10. I've also created an output folder, which is where I'm going to output the results from the utility, as well as the AsctoAsc utility itself, which can be downloaded from the TUFLOW website. To run the AsctoAsc utility, we need to use a batch file. So I'll create a new batch file using new text document and just renaming it to whatever you want, but I'll call it ARR_stats.bat. When prompted, say yes to the change in file extension. I can edit this through a text editor. I'm going to use Notepad++, which should just be a blank text document like this. Like any batch file, the first thing I do is to call the utility. This can be an absolute path or relative path. I'll just use a relative path. Navigating to the utility, I can hold down Shift and right click and copy as path and then paste it into my batch file. Because I said I'm using a relative path, I can actually get rid of a lot of this stuff, so it's just a bit smaller and easier to read. After calling the utility, I then pass the exe a series of arguments and flags. So the first argument I'm going to give it is -b, which tells it to run in batch mode, which suppresses prompts when it completes. This just means if I queue a series of them up, it'll suppress it. I don't need to sit here and tell it to run the next one. It'll suppress those prompts and just move on. The next output flag argument I'm going to pass it is -out. Now after this one, I need to specify an output file location. So after the utility sees this one, it'll then look for an output location, which will just be in the output folder here. So the batch file is sitting in this folder. It needs to go into the output folder and then give it an output file name. So output to get to the folder, and then the name of the output files, which I'll call ARR_stats. Now there's no need to put an extension on that. Finally, we need to tell the utility which process to run. In this case, I want it to run the statistics process, which will be -stat all. After the stat all flag, you then pass it the input files. You can pass it as many as you like, as long as there's 3 or more files to use. So the files are sitting in the same location, so I just need to actually pass it the names as a relative reference. So usually I would pass it 1 and then space, and then I can pass it another, and then just give it all 10 ASCII files. However, we can use wildcards similar to a Windows Explorer search function to get it to automatically pick up all the result grids that we want to input. To do this, I'm just going to remove TP, the 0, 1 and the TP after TP, and just change that to an asterisk. What this means is that everything it'll look for all text to the left exactly as is, and all text to the right exactly as is. But in between, in this location, it'll accept any text. Similar to a Windows Explorer search function, we can actually test it out to show you. In Windows Explorer, up here in the search bar, if I search that text, you can see that it finds all 10 results. It matches the text on the left exactly, the text on the right exactly, but where that asterisk is, it accepts any characters at all. So that's all I need to do. So after the stat all, it'll just automatically find all of the input grids. Save that, and now I can run it. So double click, and it's pretty quick. Once it's finished, you'll see that it's output a series of ASCII grids and 1 CSV in the output folder. So the output folder, and we gave it the name ARR stats. You can see that all the output names start with ARR stats, and then appended to that is the result type and the extension. So really we have a fraction wet output, a max output, 2 of them, 2 means, 2 medians, and 2 mins. I'll explain the fraction wet at the end, but max, mean, median, and min are fairly self-explanatory from the name. Each one has an SRC and a value grid. The value grid is the resultant, in this case, max value from all the input grids for every single particular grid cell. Similar for mean, it looks at every single grid cell and extracts the mean value, median, and min, and so on. The SRC is the source grid that produced the max value in this case. So this is the resultant value, and this is which of the input grids gave you the max value. And similar for mean, median, and min. The SRC grid uses an integer system, and the resultant input grid is a lookup table in this legend. So the SRC grid will be an integer, and then that'll correspond to one of these input grids. So I can open up, say, the median value grid in QGIS, and this will be the median resulting surface from all the 10 input files. So if I info somewhere in here, you can see the resultant median value water surface is 42.094. Now the median SRC grid, if I open that up in QGIS and info a location, you can see it's got a value 9, which corresponds to this input grid. So in this case, temporal pattern 9 produces the median value at that location. Out here in the floodplain, it's 1. There's a value 1, so temporal pattern 1 produces the median result. The fraction wet grid shows us is a ratio from 0 to 1 for every single grid cell on the fraction of the input grids that are wet at that location. So in the middle of the creek, there's a value of 1, which means that in 100% of the input grids, that particular grid cell is wet, which you'd expect because it's in the middle of the creek. However, as you move out to the fringes of the floodplain, you see there's a value of 0.2 at that particular location, which means that in 20% of the input grids, that particular grid cell is wet. You can find out more about this utility by jumping to the TUFLOW wiki in the free and pre-post-processing utilities link under AsctoAsc, which is the tool we used, and statistics. So you can see you can actually extract individual statistics. We used the stat all in this example, which outputs all statistics. However, you can output the individual statistics as well. So for example, you can output stat median if that's all you're interested in. Thank you for listening.